So this is going to be about climate change. And I know if you do environmental science in particular, I think you're pretty much forbidden from saying global warming. Not quite so strict as that in geography, but climate change. But what we have to remember for this module is we need to link it back to carbon. Because we're learning about the carbon cycle, we've got to focus on the kind of carbon element of climate change, if you like. Today, this video is going to be a relatively short overview because we study climate change in year 2 in the weather and climate module, where we go into quite a lot more detail. This is, a snapshot, I would say. And the other thing I would just like to say is, as soon as I finish this video, it will be very dated because climate change is an ever-moving thing. There's a new event or a new impact or a new solution that we're going to try, and I think it's really important, as far as possible, to be up to date with our knowledge. So I will try and update this video, certainly every year, but within that 12-month period there might be something that happens, and I would just urge you to just have a vague idea of what might have changed, okay, in case this is a little bit out of date. Right. Atmospheric carbon. How does carbon get into the atmosphere? You should know that from your general knowledge of the carbon cycle. Volcanic eruptions produce CO2, burning of fossil fuels, decomposition will release it. We also have degradation of peat bogs. Every time we cut down a tree, that tree is then not photosynthesizing, so it's not taking carbon out of the atmosphere. Might be worth just having a little bit of revision about why is more carbon going into the atmosphere from your kind of general carbon cycle knowledge. Okay, need to start with one of those kind of common misunderstanding bits. We get our heat from the sun. I don't think that is a misunderstanding. I think we're all pretty clear on that. And that sunlight, or insolation, is what we should call it, insolation. It's a shortened version of incoming, in, solar, sol, radiation, insolation. Anyway, heat from the sun comes into our atmosphere. Notice some of it makes it to the Earth's surface, some of it gets absorbed and reflected on its way through. Fine. I'm actually interested in this, the outgoing heat, because this is where people get confused about the greenhouse effect, and you see lots and lots of exam answers where people kind of go, oh, the greenhouse effect is terrible, and that's actually not true, because if we didn't have any greenhouse gases at all, the average temperature on Earth would be about -18 degrees, which is the same temperature as your freezer, okay? So actually, if we didn't have any greenhouse effect at all, life on Earth as we know it would not be possible. It is essential, actually. But the problem is because we have added to the amount of greenhouse gases in the atmosphere. We produce more CO2, we produce more methane. Now, they're the only two that we're interested in for this module because, look, they are the ones that contain carbon. Carbon dioxide, methane. We don't need to worry about nitrous oxides. We're producing more CO2, we're producing more methane. Because there is a thicker layer of greenhouse gases, more heat gets trapped. Therefore, the Earth is warming up. There is a difference between the natural greenhouse effect, which is essential for life on Earth, and this one, you can call it the enhanced greenhouse effect, the human greenhouse effect, the anthropogenic greenhouse effect. I'm really not bothered, but we need to have a distinction between the two. Okay, so humans are producing more greenhouse gases, more heat is getting trapped, the Earth is warming up. That's climate change. Why is it called the greenhouse effect? Lots of you that I've spoken to in the past are never sure about this, and I thought it would just be worth me mentioning it. The whole point of a greenhouse, which is actually made of glass, So why is it called a greenhouse? Because you grow plants in it, ladies and gents. So greenhouses, although they are actually transparent, they have lots of plants in them, so they appear to be green. Right. The whole point of the glass is that once the heat comes in, it gets stuck inside the greenhouse, and then the greenhouse is hotter than the area around it. All right? And that means that it makes sense for what's happening in our atmosphere. Just a random little fact in case you didn't know. So, CO2 concentrations are going up and up. They have done, in fact, since the beginning of the Industrial Revolution. And this website, co2.earth, so this is where we are. I'm actually recording this in July 2021. We're usually about a month behind because they have to check the data. So we're on 419 parts per million of CO2, whereas if you went pre-industrial revolution, look, we were way, way down. You cannot deny that the amount of CO2 is increasing. Exactly the same for methane. Humans are definitely increasing the amounts of greenhouse gases in the atmosphere. Where do they come from? We've already talked about that. That comes with a little bit of revision of your general carbon cycle knowledge. So here is a version. Remember, there are lots of versions of the carbon cycle, which might just remind you of some of the sources of those gases. Okay, now this is a real snapshot. The effects will change. So, for example, this year it got so hot in Canada that plastic houses began to melt. Just take a moment for that fact to kind of lodge itself in your brain. That is mental, isn't it? So it will change all the time. A little bit of Google searching, a little bit of documentary watching, etc., etc., will bring you right up to speed. But the Earth is warming up. That's definitely true. We are seeing temperature increases in everything. So the land surface air and the sea surface is warming up. The air over the sea is warming up. Sea levels are rising. Ice is melting. You know all of this. We're getting more extreme weather. So we're getting, when it rains, it really, really rains. When it's dry, it's really, really dry. All of that stuff. We're seeing more forest fires. They don't spontaneously combust, so it's not like the forest just bursts into flames. The problem is, forests are so dry because of climate change that if somebody does accidentally throw a cigarette end that's not quite put out, or I think the California one was started by a car fire, so obviously you don't want a car fire to happen, but it's sometimes unavoidable. And the surrounding forest was so dry that the fire spread from that car and took off. So the fires do not start on their own. It's the fact that the vegetation is so dry, it just burns really, really easily. We've had them in Australia, we've had them in Greece, we've had them in California. Forest fires are becoming much more normal, which is awful. We're seeing a possible extension to areas that will be affected by malaria, because warming temperatures allow the, I never remember from my biology A level which particular species of mosquito it is. Something Mesophilus. Anyway, yeah, malaria might become more prevalent. Oh, I hate this. We are seeing the extinction of species because of climate change, ice melt, stronger storms with more power, more extreme weather. People are being affected. We're seeing increased migration, we're seeing more deaths, we're seeing problems with food supply because of climate change. And oh yes, sorry, my brain went blank. That's a little positive. One of the things about the UK is, as we warm up, there are new types of farming that are being done, and it's now possible to quite successfully have a vineyard in the UK, and that's just a hyperlink to one down in Devon. Let's be honest, It doesn't quite counteract all of the negative stuff we've been learning about, but it's one little positive that you could maybe chuck in. That's a really interesting review of what's going on in the UK. It's quite an easy read. It's quite long, but it's quite easy. This is another possible positive, which if you've already learned about global governance, you probably are already aware of. One of the major shipping routes globally is from Asia to Europe. And at the moment we use the blue route. The Strait of Malacca is quite constrictive of the size of ships that you can have. Ships are now at what's called Malacca Max. They can't get any bigger because they won't fit through there. The Suez Canal, well, you all saw the news, I'm sure, about the ship that managed to block the Suez Canal, quite embarrassingly. You also have to go through the Med, and it's, you know, quite a long, difficult route. If the ice around the Arctic melts enough, it might be possible for us to use a new shipping route. Now, it's slightly shorter, which means less fuel. It won't be without its problems, but again, it's a tiny little positive that you could use. Coastal erosion will increase with rising sea levels and more powerful storms. That's an image of Dawlish from the 2014 storms, when the coastal erosion damaged the train line and the houses. We might start to see more invasive species like false widow spiders, etc. We're going to start seeing migration of people away from coastal areas, particularly low-lying coastal areas. Venice, look, is the first city in the firing line for sea levels, closely followed by Amsterdam, etc., etc. So, yeah, as I said, what I do need you to do is to kind of keep your knowledge a little bit up to date, because climate change is an ever-moving feast. This has been a snapshot, but at least it might point you in the right direction, ladies and gents.